Find the number of quadratic expressions that can be formed with the coefficients from the set 0, 1, 2, 3. How many of these touch x-axis if shown on the graph? If shown on the graph. So, this is a very simple question you can understand. But before that, what the algebraic knowledge you must have. What is the question there? Find the number of quadratic expressions. So, when you come to quadratic expressions, if I ask you the question, what is the standard form to the quadratic expression? You can think. You can say. Everybody says that it is ax square plus bx plus c. Everybody says that. But very, very few say that where a not equal to 0. It's a previous question, I say. And these are small things we generally neglect, where the questions will be formed based on such type of small things. So, ax square plus bx plus c. Understand, whenever the question is asked what is the standard form to the quadratic expression, the leading coefficient should not be 0. So, the standard form to the quadratic expression is x square plus bx plus c. And so, what is the set now given? The set given now is 0, 1, 2, 3. So, how many digits do you have here? 4 digits you have. And how many places you have here? Those numbers are to be given to ABC. That means in place of A, you have to write either 0 or 1 or 2 or 3. That means what? Here, as I already told you that A is not equal to 0, it should be filled only in 3 different ways. Understand? Which is very important thing. And B can be filled with any one of these 4 digits. So, it can be filled in 4 different ways, and C can also be filled in 4 different ways. So, the first operation we have performed in 3 different ways, second operation we performed in 4 different ways, third operation we performed in 4 different ways. All these operations, one after the other or simultaneously, can be performed in 3 into 4 different ways, which is nothing but 48. So, what you understand here, 48 different quadratic expressions can be formed using the digits 0, 1, 2, 3. So, how they will be? Let us suppose A1, 1 into x square, B also 1, let me say x, C also 1, let me say 1. That means, in this case, what I did, in this case, what we did, A is equal to B is equal to C is equal to 1. I have taken an example. So, it is a quadratic expression. Understand? Similarly, A1, B2, that is 2x, C1. In this case, what I did, A1, B2, C1. Now, if you see this carefully, the question given there is how many of these touch x-axis if shown on the graph. So, you all know the graph of a quadratic expression. It is from the lower classes itself, from your 10th class itself, you have learned the standard form of this quadratic expression. If you take it as fx, or if you take it as y is equal to fx is equal to x square plus x plus 1. And if you show this on the graph, if you put x equal to 0, then it is 1. X equal to 0, it is 1 somewhere, it will cut here. And if you see the discriminant, you know the discriminant for this one, all of you know, b square minus 4ac is nothing but 1 minus 4 is less than 0. Its discriminant is negative. That means it doesn't have any real roots. Doesn't have any real roots means it never cuts x-axis. Why shouldn't it cut x-axis? Because If it has any real roots, it will cut x-axis. If not, it will not cut x-axis. That is why it will be something like that. So, which is not our required expression. Which is not our required expression. So, let us come to the second case now. This is x square plus 2x plus 1. Then, x plus 1 whole square. This is, you can understand that it is nothing but x plus 1 whole square. If you see the discriminant of it, if you see the discriminant of this, what is the discriminant? B square 4 minus 4 into 1 into 1, 0. 4 minus 4, 0. That means it will have roots but equal roots. It will have roots but equal roots. So, what are the, where does it touch x-axis? So, if you see this carefully, when the discriminant becomes 0, if the roots are equal, what are the roots in this case now? Minus 1, minus 1. You can see that. X plus 1 whole square is equal to 0. If you equate, then minus 1, minus 1. So, it will go, if you put x equal to 0, it is 1. It will go like this. So, in this case, what we require is, how many such quadratic expressions will be there when shown on the graph touches x-axis. This is our question here. You have got one such combination. So for that purpose, what should be our approach? Just for the understanding sake, I have explained you, that is, in this case no real roots, in this case equal roots, or rather coincided roots. And if you say, if it is like this, then in this case you will have two real roots. So now, how many such expressions will be there which contains its graph touching x-axis? Then you consider b square, you consider 4ac. B square means, b square, if it is 0, can be 1, 1, 2 square, 4, 3 square, 9. Now understand, when it is 0, here b square minus 4ac, for whatever the value of 4ac it is, it will always be less than 0. b square 1, b square 1, you must have here either a1 and c0. If a1 c0, what happens? It is 1 minus 0, 1 minus 0. Then you will not have any such, that is, if you count b square minus 4ac, it is 1 minus 0, it is 1. It is 1. It is not equal to 0. So in our case, we require b square minus 4ac equal to 0. So it is less than 0, it is greater than 0. Now in this case, if you see, this is, if you put a1, c also 1, then b square minus 4ac, that is 4 minus 4, becomes 0. And for 9, you don't get any 4ac values to make it 0, because 4 is multiplying ac, you will never get this odd number. That is why in this case also you will not have any such equal b square minus 4ac equal to 0. So if you go on counting like that, so you will get minimum of how many you will be getting, you can understand. So in this case it is, please, yes please. Hello, yeah.
I'm having a doubt now in online class. Sir, I've done this problem using permutations, so we can fill B and C in 4p2 ways. So, and we can fill A in 3p1 ways. So total becomes 12 into 3, 36.
Please, can you repeat the question?
Yeah, this above question, sir. A square plus B plus C.
Okay. In this case,
B and C can be filled in 4p2 ways.
B and C can be
Filled in 4p2 ways. using permutations and combinations. Permutations.
Now we are today discussing now principle of counting. What is your doubt exactly in this one? Because I explained that A can be filled in 3 different ways, and because A is not equal to 0, we can choose 1 or 2 or 3, and B can be filled in
3 ways. Okay.
4 different ways. C can be filled in 4 different ways. So all these operations can be performed in 3 into 4 into 4 different ways. You first of all, you avoid permutation. We will be deriving the formula for permutation basing on principle of counting only. So in this case, do you have any doubt in this one, 48?
Okay. No, sir. No.
Okay. So
I just calculated in another way, so I got.
You are saying that it is 4p2, no? We'll be coming to that. We'll be coming to that.
Can fill in 4p2.
No. 4p2. What is its value? 4p2 is 4 into 3.
4 into 3.
No, it's wrong. No?
Yeah, then total,
Here it is. What you're doing is you are not repeating. That means you understand. 4p2 is nothing but 4 into 3. Why 3 reduced here? Because repetition not allowed in this case. But you don't have any such case here. Repetition is allowed. So this is like that. So this permutation is without repetition. I am not talking about the repetition or without repetition, anything like that. Without repetition case, we use permutation. We'll be getting that later. Okay, you can count like this, and you can see the number of such expressions which touch x-axis will be counted in this way, wherein you take the combinations. I have already shown you a combination like B is equal to 2, A is equal to 1, C is equal to 1. So in this case, B square minus 4AC becomes 0. So what should be this expression? X square plus 2x plus 1. You count such type of expressions, and how many such expressions will be there touching x-axis. Just you see that.